we're on day 2 of classifying matter, and now we're getting into chemical and physical properties and changes. So there's an outline that you should have in front of you. The first one that we address is physical properties and changes. So the next one is chemical that you'll see after that. Physical changes, it's going to be when the same substance remains. We do not change the chemical composition of that substance. So it remains unchanged. It doesn't change. All of these things can be observed and measured without changing the matter itself. So for example, if we look at physical properties, we can break that down further into extensive and intensive physical properties. Both of those are considered physical. That's what we're talking about first. So extensive properties are extra, right? They depend upon the amount of matter that's present. Really doesn't do much to identify the substance. It just tells you something about how much stuff you have. So if I said, hey, I have this stuff and I've got, 5 grams of it, or yeah, I've got this matter right here and it weighs 3 ounces. That doesn't really tell you much about it. Instead, it's just going to be an extensive property. So extensive properties depend upon the amount of matter that is present. You have examples listed there for you: mass, length, volume, things like that. Not very descriptive, not true identifiers of what that substance is. So you should be able to differentiate between extensive and intensive. Intensive physical properties do not depend upon the matter itself. Instead, they help they do not depend upon the amount of matter. I'm not sure if I said that. And they are a little bit more identifying. So for example, if I said, yes, I have this element and it's yellow, that might help at least to help you decide that maybe it could be sulfur. Or if I said, yeah, I've got a substance and it has a density of 11.34 grams per cubic centimeter. Doesn't matter how much of that I have, it has that density. That might help you decide, well, that's going to be lead then. Lead has a density of 11.34 grams per cubic centimeter. So some properties that are intensive physical properties are things like color, density, freezing points, melting points. Those don't change depending upon your amount. Those are going to stay the same. Malleability, that's the ability to be hammered into sheets. So metals are very malleable. Ductility, that's the ability to be pulled into wires. Again, metals are very ductile. Conductivity, in other words, the electrons flowing within a substance. So all of those are going to be our physical properties, and more specifically intensive physical properties. Then we can look at some changes that take place, and we're starting with physical changes. So if I were to just go to Margaret's paper and rip it in half, well, that's a physical change that has taken place. All I've done is change the amount of matter that's present, right? I just ripped it in half. It's still paper, so I haven't changed the chemical composition. That would be a physical change. People are usually pretty good at understanding those. The tougher ones, if anybody misses these, it's typically those two right there. A change in state, also known as a change in phase, same thing. A change in state or a change in phase is a physical change. In other words, if I went from H2O, that is a solid, ice, and I heated it up on my stovetop and turned it to H2O that's a liquid, it's still H2O, and I boil it, it turns to steam, it is still H2O. So whenever you change phases or states, it is merely a physical change. You have not changed that chemical composition. So that's one that people typically miss. The other one that people miss a lot has to do with dissolving. If you were to see that listed as a property, a physical property, it would be listed as solubility. So the solubility is a physical property. All right, so, and how something dissolves, let's say if I took some sodium chloride and I threw it into some water, made some salt water, well, what happens, and this really goes beyond the scope of what we're talking about right now, but what happens is these, you get some sodium ions and some chloride ions. That's the dissolving process, but you could, through physical means, you could go through some evaporation and get it back to being sodium chloride. So you have not changed the chemical composition of that substance. Solubility, dissolving, there is no change in the composition. All right, and this diagram is again just illustrating that if you go from something being a solid to a liquid to a gas, you're not changing that chemical composition. All you're doing is changing the relative position and movement of those molecules or atoms. Okay, so now we're going to move into chemical changes. And if you have a chemical change that takes place, then a different substance is being formed. That's the big thing to notice there. So if we talk about these changes, we're really describing how these different substances interact with other substances. So you're looking at an interaction of substances, how they work in the presence of other kinds of matter. Chemical properties, if we talk about the properties, again, it's describing how it behaves in the presence of other matter. So the type of changes, chemical changes that will take place. Examples of some words that you would see that would describe chemical changes taking place, it would say something like reacts with, right? So a reaction with oxygen, with water, whatever it might be. If you see the word corrosion, flammability, combustibility, anything that has to do with fire and burning is definitely going to be an example of a chemical change. So that's a reaction with another substance is what's going on. Ways that we can identify a chemical reaction, and you're going to have to think about these things when we do our little lab, which is partially today and partially tomorrow, but some things that can be thought of that help identify a chemical reaction. And there's a little bit of a gray area in here, but I'm going to let you guys try and figure it out as you go through this. But one thing might be a color change. Actually, let me just go to the next slide for this. We could have a color change if you see, this happens to even be something known as phenolphthalein. So in the presence of a base, it turns this bright pink color. You have this color change that takes place, so therefore you have a chemical change. You can have gas formation. Maybe you mix a solid and a liquid together, and all of a sudden all this gas is produced. That's usually identifying a chemical reaction. You can have a precipitate that is formed. So if you were to take, in this example, it's kind of hard to see, but you're taking two clear liquids and putting them together and getting this yellow. More typically, you might maybe take two clear liquids, put them together, and all of a sudden you get this white powder, this solid down at the bottom. So the word precipitate just means that you have some sort of insoluble solid that is formed. It's not like precipitation, rain. You get a solid that's formed. And then finally, an energy change can occur, and that's usually, most frequently, it's going to be a change in temperature. More often would be heat is produced, but you could also have heat is removed in the process. So some other ways that energy changes might be evident would be the production of light, sound, some different things like that. Okay, so those all identify chemical changes. Now we have some examples on the flip side of your sheet. And we are just going to, you guys are going to call out the answers because I know you know this stuff. First one, we're just thinking about properties at this point. So is this a physical property or a chemical property? If I said this thing is blue, what would that be? Physical. Physical. Let's go further. Is it an intensive or an extensive physical property? Intensive. Doesn't matter if I have a little bit of this stuff or a whole bunch of this stuff. It's still blue. So it helps to describe that substance. Color is an intensive physical property. What about density? Physical or chemical? Physical. Physical. It doesn't matter. It's not a reaction with anything. It's just, well, you guys answer. Is it intensive or extensive? Intensive. Doesn't matter if I have, let's go back to our lead weight. If it's 11.34 grams per cubic centimeter, I can chop it in half, and I still have a density of 11.34 grams per cubic centimeter because I've halved both the mass and the volume. All right, flammability, what does that sound like? Chemical sounds like fire, right? So that is going to be a chemical property. It's how it's reacting with the oxygen. Okay, solubility. Physical. And again, that's going to be intensive. I'm not sure that we talked about that. Reacts with, blah, blah, blah. Chemical. So remember, chemical has to do with how something reacts with something else. So here it's just telling you it's reacting with acid and it forms this different substance. So that's chemical. Supports combustion. Chemical. Sour taste. A taste, what would that be? Physical. What do you think, intensive or extensive? Intensive. Melting point. Physical. Ice. H2O, it melts at 0 degrees Celsius. Does it matter how much you have of it? An ice cube or an iceberg full of it? Nope. So therefore, it is intensive. Reacts with. Chemical. Reacts with. Chemical. Hardness. What do you think? Physical. Boiling point, that's the same as melting point, right? So that's going to be physical. Again, these are intensive. It doesn't have anything to do with how much of that stuff you have. Can neutralize a base. Chemical. So eventually we'll start talking about how acids and bases, that's a neutralization reaction. They form a salt plus water. Okay, luster, that means shininess. Physical. Again, that's going to be intensive. And odor, physical. And that would be intensive is what we're going to go with there. Okay, so now we've looked at the properties, and there's kind of it's a fuzzy little transition between properties and changes, but this is just thinking about the properties. Now we think about these things occurring. Is this a physical change or a chemical change? So first one, sodium hydroxide dissolves in water. Physical, there's our key word, dissolves. Hydrochloric acid reacts with potassium hydroxide, chemical. This is beyond the scope right now. You certainly don't need this, but HCl plus potassium hydroxide. We could create these new things that are produced. That's what it's saying. It produces a salt, which is the potassium chloride plus water is what ends up happening. So it is a chemical reaction. A pellet of sodium is sliced in two. Physical. Water is heated and it changes to steam. Physical. Sounds kind of sciencey, but it's just a physical change. It's still H2O. It's not changing the chemical composition. Okay, potassium chlorate decomposes to form potassium chloride plus oxygen gas. Chemical. Again, you don't need to know this, but that's what's going on. And then it would have to be balanced, which I'm not going to worry about right now. Iron rusts. Chemical, because what's going on there is iron, in the presence of oxygen, is forming an iron oxide, which again is unbalanced at that point. But, okay, when placed in H2O, a sodium pellet catches on fire as hydrogen gas is liberated and sodium hydroxide forms. Chemical, that's definitely a chemical reaction right there. Evaporation. Ice melting. Milk sours. Which one? Chemical. Maybe this is a good point to write ourselves a little note that all chemical changes also have physical changes. Not the other way around. All chemical changes also have physical changes. So milk sours, we all have seen that nastiness when dairy just gets all clumpy, right? So you've got that physical component that goes along with it, but there was a chemical reaction that caused that to take place, but there's physical that goes along with it. Okay, sugar dissolves in water. What do you want to say? Physical. There's our key word. Wood rotting. Chemical. Pancakes cooking on a griddle. Going with chemical. You can't get it back. You're changing that chemical composition of the eggs and the whatever's in there. Grass growing on a lawn. Which one? Chemical. Y'all remember a little thing from biology known as, uh-oh, it's not writing. Here we go. I lost track of my writing. Synthesis. There we go. So, I just moved everything. There we go. So, grass growing on a lawn, photosynthesis, that's, you've got that chemical reaction taking place that causes that process for that grass to grow. But you've also got, of course, a physical component with the length of that grass. Okay, a tire is inflated with air. Physical. Food's digested in the stomach. Chemical. And water is absorbed by a paper towel. Physical. Beautiful. You did it. We're done.